Inside the cab of a tower crane, 200 meters up, the city feels very far away. Down below, the building is finished. Tenants signing leases, cleaners vacuuming the lobby, as if the job is done. But up here, your crane has no way off the roof. What happens next is the tower crane trick almost no one ever sees from the outside. A rooftop giant made of steel and bolts taken apart until it fits inside an elevator. To understand this trick, we first need to answer a different question. How does a tower crane end up on a skyscraper? You know the picture. A crane stands on the ground, anchored in a big concrete block, and balanced by concrete counterweights. When the job is done, a mobile crane takes it apart and it disappears. On tall towers, that doesn't work. As buildings push higher, wind becomes more aggressive, streets get tighter, and lifting every beam from ground level becomes painfully inefficient. That's why engineers use tower cranes that climb with the building. They're anchored into the building's core or sit on the roof, always just above the last completed floor. Then the moment comes. The concrete truck can shut down and the tools can be packed away. But you can't just pack away the crane. It has become part of the building. A tower crane doesn't just appear on the roof. It starts its life much lower down. Engineers pour a massive concrete block at ground level, reinforced with dense steel rebar. That foundation is critical because it has to take a lot. The load swinging back and forth on the crane, the wind pulling at the crane's lattice, and the weight of the crane itself. On top of this foundation, the steel lattice tower is erected. At first, a regular mobile crane on the street can still help with the assembly. Then the tower crane takes over the site. It lifts rebar, formwork, steel beams, everything needed to build the lower floors, but the building keeps growing. And the crane has to grow with it. Here's where the first trick comes in. Inside the mast is basically a gigantic hydraulic jack, a climbing frame. It pushes the entire upper machine, cab, slewing unit, jib, counterweights, up by the height of one mast section. That opens up a gap. Workers slide a new steel section into that gap and bolt it in place. Then they repeat the process. Imagine a telescope extending ring by ring, except each ring weighs several tons and is assembled by hand. In the end, the crane is perched near the top of a tower that didn't even exist when it first started working. And that's exactly when the crane quietly turns from the site's biggest asset into its hardest problem. From the street, the building now looks complete. The facade is closed, elevators are installed, the roof is packed with equipment. But on that same roof, a tower crane is still standing. Here's the catch. The climbing system that helped the crane grow is not a simple elevator. It's designed for a very specific range of heights and loads. During dismantling, crews can reverse the process only down to a minimum freestanding height. Below that, the geometry and weight distribution no longer allow the crane to safely lower its own upper structure all the way to the street. So what do? No mobile crane can reach 60 or 70 stories up with any meaningful lifting capacity. The physics of leverage and stability just don't cooperate. And you can't leave tens of tons of steel sitting on the roof forever. You end up with a strange situation. The crane has done its job, and yet there's still this one machine stuck at the very top. So what do you do with the giant you've trapped? The first step, make the giant as small as possible. Using the same climbing frame that once pushed it upward, the crew now works in reverse. They pull mast sections out and lower them down through the frame. It's difficult, dangerous work at extreme height, often so windy that you can't even hear the person next to you. But it works. Segment by segment, the tower gets shorter. Picture the telescope again, this time collapsing ring by ring until only a stub is left. Each removed mast section is either stacked safely on the ground or temporarily stored on intermediate floors. This continues until the crane reaches its minimum freestanding height. Now there's only a short mast left, with the slewing platform, machinery house, and maybe a shortened jib on top. Too low to keep climbing, and still far too high and too heavy for a street-level crane to pick it off in one go. At that point, a new character enters the story. On the roof, engineers assemble a much smaller helper crane, often called a derrick crane. In many cases, the main tower crane itself lifts this helper up in pieces before it begins its own dismantling. Now the roles are reversed. The former giant is immobilized. The smaller derrick, firmly anchored into the roof, starts taking the big crane apart. Short jib sections, counter jib, concrete counterweights, machinery house. Each piece is disconnected and then lowered either all the way to street level or to safe staging areas on lower floors. When its job is done, the derrick is left alone on the roof, and now it's the machine that's stuck. The solution is the same idea applied one more time. An even smaller hoist or mini derrick is brought up, and the game repeats. The larger helper crane is broken into components that are light and compact enough for this smaller one to handle. In the end, the smallest crane takes itself apart into steel frames that fit into a freight elevator, drive units you can move on small carts, components narrow enough for stairwells. Think of Russian nesting dolls. The big crane is dismantled by a medium-sized crane, the medium by a small one, and the small one ends up in pieces that ride down in the elevator, just like desks or refrigerators. Only in extreme special cases do heavy lift helicopters come in to pick off the last components. It's a neat trick, and it only works because someone ran the numbers years in advance. We look at roofs and walls of buildings and think of apartments or offices. Architects and structural engineers think of loads that have to be carried. They have to calculate exactly how forces flow through columns, walls, and slabs to hold the tower crane safely while the building itself is still curing. All the while, wind is the constant enemy for the crane structure and for the workers. A single crane component can behave like a sail, and a swinging load 200 meters up becomes a danger you can't just catch with brute force. Work must be stopped when the wind is too strong. At the same time, every extra mobile crane on the street and every hour of road closure in a dense city costs serious money. Special dismantling. Derricks exist for exactly this reason, to do as much as possible directly from the roof. Behind the scenes, crane operators, riggers, fitters, and site engineers work through a strict step-by-step plan. Every lift is checked, every radio call confirmed, because one mistake doesn't just damage steel, it puts everyone below at risk. While all of this is happening, almost nobody down below notices. One evening, people walk home under a skyline full of red crane lights. A week later, the lights are gone, the roof is clean, and no one saw the last pieces riding down the elevator shaft. What's left is a finished building, one that first had to get rid of its own tools before anyone could move in.